Aloha. You're watching Cradlepoint, part of Ericsson's demo series. I'm Peter, and our demo series is when we get hands-on how-to with the Cradlepoint experts. And today I'm excited to have Matt Ringhofer with us. He's a senior consulting engineer covering our SD-WAN solutions. And I understand, Matt, we're going to talk about intelligent bonding today, aren't we?
Yeah, that's right. And thanks for having me, Peter.
Hey, man, anytime. We love doing demos. So let's get right to it. Intelligent bonding for SD-WAN solutions. Hit it.
All right, great. So I have this environment that I've stood up. It actually is a live platform. I'm working with a few sites that I've added. Within those sites, I've created and defined resources, and those resources are applied to policies. Now, our platform is based on zero trust. So I define resources, those resources get attached to policies, then I can access those resources. Without that, it's denied by default. So I can be very prescriptive in what I want to allow access to.
And when you kind of mention resources, what is that? Like target servers, URLs?
Exactly right. So these are target servers. I have a data center site that I've defined. And within that data center, I have video servers, I have file servers, I have a web server. So I could be, very specific in how I define that based on IP, based on port protocol. And that basically allows that segmentation to define a policy very specific in what machine I want to access or what user I want to access that machine. So I'm going to jump into traffic steering. And traffic steering is really where all of our SD-WAN is configured. And within that is the intelligent bonding. So that's really where we're going to focus today. And intelligent bonding is really a great sort of tool to be used within the toolkit of SD-WAN. It's based on a specific use case. And we actually leverage 3 different types of WAN bonding. And I'll describe each of those. But before I do, I'm just going to quickly type in a generic name here for my WAN bond and go through that configuration. So the configuration is pretty simple, where I take my available WANs on a specific site router, and this can be applied to all of the routers globally as well. But I have cellular, Ethernet, Wi-Fi as WAN, and device WAN profiles. So for the first, I'm going to select Ethernet. On my second, I actually have a CBRS network set up. And in that CBRS network, I can select cellular and define that by the provider, which is really nice because I could have multiple providers within my cellular interfaces. I can define it based on, say, Verizon and AT&T, and it can be very selective. In this case, I'm going to select device WAN profile. And the reason why I like to do this sort of as a best practice is for network slicing. And when that's available, I can use the same methodology to define how many network slices there are by a specific device WAN profile. We can support up to 8 different network slices on a SIM. So, if you think of a WAN bond, when we create 1 or 2 like I am today, it doesn't really much matter. But when I start to add 5 or 6, I want to be very specific in how I tailor these bonds. So the very first thing you might notice is I'm looking over at the percent weighted. And that's because we actually weight traffic. And that's really our first form of intelligent bonding, is weighted bonding, where I can be very specific in how much traffic I want to go over a particular interface. In this case, I've set Ethernet to 60% and I've set my cellular interface to 40%. Now, this is important because it more efficiently utilizes bandwidth. And why that's different is most algorithms in traffic steering are going to look at something like a spillover or a round robin type of algorithm. Round robin is simply going to take something like a file transfer. Let's say you and I are transferring FTP. You put a FTP transfer on Ethernet, which is very large. I put one on my cellular interface, which is very small. And then we keep doing that. You keep putting large transfers. Well, you're going to fill up that Ethernet interface very quickly. And I'm going to have a whole lot of room left on my cellular interface. So we're not efficiently utilizing that. In this case, it's really all about cost savings, right? You're paying for this bandwidth. You've subscribed to these plans. You want to get everything you can out of them. And not all WANs are created equal. My Ethernet and my cellular profiles could be a little bit different. So I want to set those based on how they are relative to each other and how I can actually utilize that throughput more efficiently. So I've set those weights. They're all in place. And I can leverage this within any of my steering rules. So the second one I want to point out, which is really cool to me, and I use it quite often, it's flow duplication. So this is a form of intelligent bonding, which actually duplicates packets across all of my WAN link members. Now, I would typically reserve this for mission critical applications. And we see this in public sector all the time. We work with EMS, fire, and police, and they have applications that have to be up 100% of the time, all the time. So think high resiliency when we talk about flow duplication. But there's also another case for this, which is, say, in branch, where we're utilizing applications that are very small in nature based on throughput, something like voice over IP. And VoIP is very susceptible to problems and disconnects. If you disconnect a VoIP session, it may take a long time, even up to minutes, to reestablish those connections. And because we're not actually filling up the link with a large application, it's okay to duplicate it. We're not going to see much effect from it. But what we are going to see is that higher resiliency on a VoIP connection, so we don't have those call drops. And we're also going to maintain better forms of jitter because we perform jitter smoothing within this bond as well. So we could actually increase the application QoE at the same time as providing that resiliency. Now, my third is going to be what everybody considers typically the norm for bonding, and that's aggregate bonding. It's taking all of these WAN members, these interfaces, and creating a logical aggregate interface. Let's say my Ethernet link has 100 megabits per second, and my cellular interface has 100 megabits per second. Now, most people think, well, I'm going to get about 200 megabits per second if I bond those together, and that's close to true because we do have overhead. We have to account for the actual overhead of, how much encryption is happening. There's going to be some forms of how much MTU and MSS is going through the pipe, and we account for all of that, but typically reduced by about 10%. So in that example where I have two 100 meg link members, we actually see about 180 megabits per second, all things being equal and in optimal conditions. And I take that with a grain of salt, right, Peter? Because everything isn't equal all the time, and we have to account for latency and the differences between the bandwidth profiles. So we can account for that, adjust for it, and actually understand how much aggregate throughput we're likely going to get out of bonding all of these different links together. Now imagine if I add 5 or 10 links in here, I could have a massive pipe to push huge amounts of file throughput, in a single session. So it's pretty cool technology. But just to kind of summarize what I just talked about, we have those 3 intelligent bonding features. One is weighted balancing. That's really a cost savings. Make sure I utilize the pipe as best as possible with my throughput. We have the flow duplication, which is really about resiliency. It's the mission critical apps and even those low throughput applications that I want to maintain a better QoE for. And then flow aggregation, which is taking the sum of all those member links, aggregating it into one large pipe.
Okay. Pretty cool. And that aggregation one, it doesn't really matter whether it's a wired or a cellular connection. You can still kind of match those, bond those together, and use them both together.
Absolutely. And it's a great point because we're wireless optimized, right? That's what Cradlepoint does. It's the heart of everything we do. So we do account for that. There's going to be variation. And one big difference between wired networks like Ethernet and cellular is the variability in cellular networks. So we do have to account for those changes that are often happening, and we're measuring that data consistently. So we do that measurement passively. In most cases, we don't want to put anything else on the wire and actually affect how much throughput we can gain.
So now when you configure these, do you have to add, or once you configure those and set them up, they're just ready to go?
Yeah, so I basically created the bond and I'm attaching it to a site. In that case, it's ready to go. I could have multiple sites with the same profiles. Think of a fleet of vehicles. They're sort of cookie cutter. So I can just attach any of those sites that I want this bond to apply to, save it off, and the bond has been created. So all I have to do is attach it to a rule. And that rule is pretty simplistic. As soon as I get into the rules, I'll select add. And I'll take my example of voice over IP. For the VoIP application, I'll just give it a name and select where my sites, my source sites are going to utilize this. Now, typically, I like to select any if I have sort of that cookie cutter pattern, because any site that comes onto this, it's going to globally affect all those sites. In this case, I'm just going to select my headquarters, add it, and select my application. Now, we recognize about 3,500 plus applications through DPI, but I'm going to select application category. And I like to do this for something like VoIP because I could be using soft clients. I could be using a phone system, IP phones on the network. And it really doesn't matter what protocols are being used. We're going to identify that VoIP and actually use the steering rule for that. Now my WAN selector is where I select my bond in WAN, and I'm going to create this allow failover to happen. And the reason why I like to do this is if I add additional WAN links in the future, I'll be able to fail over in case that bond fails. You know, imagine my 2 links for my VoIP fail, both of them. I still want to fail over to a third link that could be available. Think satellite, think another cellular. Now, the traffic class is what defines that bond and how I utilize that. So I'm going to select my real-time traffic, and I'm going to actually expand the class here. And this is where I have my performance attributes. So I could set my latency, my jitter, and actually signal strength, something unique to wireless WAN, right? We want to be able to understand if my cellular connection is degrading before it happens and proactively move these conversations and you know, all of these flows. Now, I can also use other things like forward error correction in combination with my bonds. I can use these just as a standard rule as well, and multiple WAN, which defines things like round robin, spillover, things we talked about. But what I've done is I've selected flow duplication. So we have a standard template. You can set, you know, whatever type of bonding you want. So there's the 3 we talked about. And flow duplication is going to be most appropriate for what I'm doing in VoIP. So everything is set in this profile, and I simply select add. And that gets pushed out to all the devices globally within the network, and that policy is going to be in effect. Now I'm just going to quickly add a second one because we talked about file transfers, and file transfers is going to use a different bond. So I'll say transfer, and I spelled it wrong. So let's do a quick update. And in this case, I'll just select and keep any. Now, imagine any site has the same profile, same bonds going. I have my headquarters, my data center. If they all have things, you know, that are very similar, I can roll that out to all the devices. And in this case, I have my application. You know, think of anything file based. If I type in file, I have all these different SaaS applications that can be selected. But again, I'll take the easy route, select application category, and I'll choose something like file management or transfer. I could add them both, doesn't matter. But my WAN selector does sort of the same thing. I'm going to enable that WAN bond, and I'm going to now select my business critical class. And that business critical class is looking at bandwidth aggregation. So now I can leverage that to make these large files. Let's say I'm sending that one large file, it gets sent down, and I add that.
Pretty cool stuff. Wow.
And that's it. Within about 10 to 15 seconds, I'll be able to provision all of the devices. The rules will be in effect. Those steering policies are going to start my flow duplication and my flow aggregation.
Pretty cool stuff. Thanks, Matt. Hey, so if you want to learn more about any of our intelligent bonding solutions, you can certainly visit Cradlepoint.com. If you have further questions, please add those in the comments and we'll be happy to reply. And if you enjoy content like this, you know what to do. Hit the like, the subscribe, and the share. Thanks a lot, Matt.
Thanks, Peter.
Nice job today. So for my buddy Matt, I'm Peter, and we're with Cradlepoint. Thanks for watching.
Take care.